In this presentation, I'll show you the LiteBase point-to-multipoint design software. This is a small utility that provides a strong feature set that aids in the layout of point-to-multipoint radio networks. In this slide, I'm showing you an image of the tool, and I will walk you through it and show you some examples of how it works. And in doing so, I'll explain all of the fields, but you'll see it's quite straightforward. So I'm going to start first with discussing the feature set because it'll help us to understand what's possible. The tool takes input in the form of a text file, a comma delimited CSV file, which defines all of the possible links between all of the sites and, of course, the sites themselves. So the tool has an input saying, this is all the potential links and sites that we want to use on our network. From that, it'll design a network. Now, I've shown on the left, this is a Google Earth plot of that particular CSV input, and you can see all the white lines are showing all of the links that we know are viable. They're not blocked, they will work, and they can have good performance. So this is our input. On the right, I'm showing a network that the tool has created, and it can create many versions of this network based upon whatever the criteria are that you set, which I'll talk about in a few moments. So it sets the BTSs, which is the centers of these stars that you can see in the plot, and all the CPEs connecting around to them. It sets all the sectors, the sector azimuths, sector beam widths, and the CPEs are attached to specific sectors. So the functionality of the tool, I'll just run through this quickly. We import a link data file, a CSV file of all viable links, and each row in the file is a single link, which has site A and site B identified with the coordinates and a number of other parameters. When you do that import, the tool allows you to assign the option that any site can be a BTS. The alternative is that only sites in position A of the link data file can be used, and that allows you the possibility of restricting which sites can be used for BTSs upfront. From all the potential BTS sites that it identifies, the tool then decides which sites are most suitable to operate as BTS sites, and that's done by maximizing connectivity to other sites. It then sets all of the BTS sectors, azimuths, and beam widths to best fit the CPE locations that attach to these selected BTS sites, and then it assigns the CPEs to the BTS sectors. So constraints that you can set are you can preset the azimuths that are allowed for the sectors. You can set a number of them and it'll find the best preset azimuths to fit the case. Or you can allow the tool to find the sector azimuths on its own that are optimal to basically cover the CPE locations that it's attaching to its sectors. It sets the beam widths based upon checkboxes, basically selections of potential beam widths that you're allowing. And you can choose a number of them, and it'll find the best one from the selection that you've made. You can limit the maximum number of sectors on a BTS and the maximum number of CPEs per sector. And you can also limit the maximum megabits per sector, basically because of the input power or input traffic that's coming from the CPEs. And as you saw, you can create some Google Earth plots. I'm showing in this slide an input link CSV file, and it's been opened in Excel. So the row 1 is the headers that must exist in the file for the tool to recognize it as a valid input. It's not case sensitive, so it doesn't matter if it's uppercase or lowercase, and it doesn't care about the position of the fields within the file. You can move the column positions around, and you can insert additional columns if you wish. This slide shows you a list of, from an input file, a list of BTSs that it's selected as the ones that are most suitable because they have the highest CPE connectivity. So you can see in the list, the top one, sub 149, can connect to 26 other sites, which would be CPEs. I'll explain to you a little bit how the sectors are assigned, the azimuths, which CPEs connect to which sector. So the tool rotates from a start angle around each of the BTSs, and as it rotates, it connects or picks up CPEs that are that are within that angle and attaches them to the new sector that it's creating. So each time it comes across one as it sweeps around, it finds CPE sites that are connected, have basically valid links that go back to that BTS, and it assigns them to the new sector. It does, of course, limit them based upon maximum number of CPEs allowed per sector and per BTS, as well as the maximum megabits that are allowed on any individual sector. As it rotates, it stops when it hits the maximum beam width that's allowed for any given sector. Um, the start angle is basically dependent upon whether or not we have predefined sector azimuths or not. If we don't, it starts at 0 degree azimuth and rotates from that. If we do, it looks at the azimuth of the sector it's looking at and then subtracts out half of the maximum beam width that's allowed. When it is assigning the beam width of the antenna to the sector, it looks at the CPEs that is connected in this process. So it looks at the first one, which has the lowest azimuth from the BTS, to the last one, which has the greatest azimuth from the BTS, and the difference between those two determines the sector angle, or basically the beam width that's required in order to cover those CPEs, and it will select an antenna beam width from our allowed set of selections for that particular sector. When it finishes the first sector, it moves on to the second and continues around through all of the sectors it's adding until it gets back to the start angle. Okay, I'm going to show you the actual tool here with some real examples, and it'll be very obvious how it works, and it's quite straightforward. So we start with browsing for the link data file at the top left here, and I have a few of them. I'll just choose one. So it goes and it loads that file, and it tells us a little summary here of what it found. So it loaded 993 links, 104 sites, and from those 104 sites, it found potential BTSs equal to 104. Now, the reason it's the same number is because this checkbox on the right says all sites are considered as potential BTSs. Now, as I said, there is an option where we can only look at sites in position A of the link data file, and I'll show you an example of that afterwards. But for now, we'll work with this. The next step is we decide whether we want to predefine the sector azimuths or allow the tool to find them. And that's done by selecting one of these two radio buttons. So we'll go with finding the tool finding the best azimuths using this radio button selection here. After that, we decide which beam widths we're going to allow the tool to choose from. I'll just check off these four. So that means it'll find from this set of four the one that works the best for each of the sectors. We can set some constraints, as I said, maximum number of sectors per BTS, maximum CPEs per sector, maximum megabits per sector, and we can also set the megabits per site. Now, the tool doesn't know initially how many megabits each site requires as traffic. That may be something we add later as an enhancement to the tool, perhaps as an input on the CSV file, but for now it doesn't know. So if we're going to limit megabits per sector, we need to set a megabits per site. So I allow you one here, one entry that covers all CPE sites. So I'm using 1 megabit. We can also do the defined sector azimuths as a second case, and I'll go back to that, but that's what this area here in the tool is about. So then we click Analyze, and it goes off and from all of the 104 sites, it finds the best ones with the maximum connectivity, and they're shown in decreasing order of connectivity to CPEs, and tells you what the names of those sites are. We then find the sectors using the algorithm I explained, just by clicking this button. And then if we click on a BTS, we can see the sectors that it's chosen. So the azimuths of the sectors it's chosen are here with the beam widths, and you can see it's chosen different beam widths dependent upon the sector because it's covering geographically CPEs in different positions. Now, if we click on any one of these sectors, we can see all the CPE sites that are attached to it. Now, because we've used an algorithm that finds maximum connectivity, which ultimately means minimum BTSs, we may have cases where we have sites that don't actually connect because they don't have valid links to these sites that have been selected. So there's some outliers. And we can see what they are by checking this checkbox here. And in this particular example, there's one that doesn't connect. So I'll show you these results in Google Earth, but we'll start first by plotting all sites and paths that came in, basically our starting point. So we click on this button and it opens Google Earth, and you can see everything here. Now, we can click on any of the icons for the sites to find out its name. Tells us this one here, for example, is CDA R0059. So basically you can identify the sites that way. Now just clear this out so I can show you the results of the actual analysis. So now with my network designed and all of the sectors and azimuths, beam widths and so on, and CPEs assigned, I can plot it. And I can plot all BTSs or selected BTSs. So let's start with the entire network, which is all BTSs. And we have a plot button down here. And it's basically brought up the map of the network that it discovered. Now you notice that on the left here we have three layers. We have sites, sites not connected, and paths. So the sites, of course, are the ones that are in our design. But if we want to see what wasn't connected, let me just turn off the paths and the sites, and we can see there's one lone site here left over that did not connect because it didn't have a valid link to the BTS that we chose, or BTSs that we chose. And if we click on it, we can see it's sub 125. Now let me go back to our tool. And you can see if I click on Show Unconnected Sites, that sub 125 is here. So we get to see it in two different ways. Okay, the next thing I'll show you is using Define Sector Azimuths. So we'll click on that option here. We have a number of them set. I'm just going to delete them for the moment. Actually, I'll delete a couple of them. I'll leave these two. So let's just say we only want these two sectors at this particular site, and we're going to use 90-degree antenna. Okay, so with these selections set, and I could also set some limits here, but I'll leave that off for now. So and then I analyze it, and it finds all the CPEs that are possible. And you can see there's more of them because we've limited the sector angles, which means that we ultimately have to have more BTSs. You also notice that we can't assign sectors, and the reason is that it's pre-assigned them from our settings here. And if I click on any one of them, I can see what it's done. Now let's plot this and see what it looks like. And you can see it's a significantly different network. And we can then take a look at what didn't get connected. So turn off those two layers, and you can see I've got three sites here that were not connected using this design. So we have more BTSs and less connectivity. And as before, if we want to see unconnected sites, we can see them by clicking this on, and it tells us here what they are. Okay, second to last thing I want to show you is loading the data, but without allowing all sites to be BTSs. What we'll do is we'll just take those in the site A position, as the note says up here. So we'll go and browse for the file again and load it. And I'm going to go back to best sector azimuth and put on these selections, and we'll assign it. And you can see we have them here. Find the sectors. If I look at them, they're there. And let's take a look at unconnected sites, and you can see there's quite a few now. So let's plot it. And there's our network. And if I turn off those layers again to see the unconnected ones, you can see there's quite a few more again. So that's another option that we've got. So the last thing I want to show you in this presentation is the Excel report with all of the data. We can create an Excel report including CPE links, or if we just want to see the BTS sectors, we can turn that off and just get it. But I'll show you everything here. It takes a few seconds to load, basically to create that file. So I click the button, and you can see on the left here that it's working. This red indication is telling you how it's building out the file. And when it's finished, it'll bring up Excel and show you it. There we go. So there's two tables in this Excel report. The one on the left is the BTSs with its sectors. So you can see here, this is sub 149. It has 4 rows because there's 4 sectors, which have their own beam widths and azimuths, number of CPEs and total megabits assigned. You can see the coordinates, and you can see the total number of BTSs, rather CPEs that have been attached to this BTS. And it's the same for all of them. The number of rows for any particular CPE is a function of how many sectors there are. So here you can see there's 3. On the right, we have all of the links in the systems. We have site A site and site B site with their lats and longs, which BTS is assigned to which sector number, and what the BTS azimuth to the CPE is. This is not the sector azimuth, it's actually the azimuth of the link. So that's essentially the tool. I think it provides a strong feature set to aid in laying out a network. And from anything that it creates, of course, you can edit and change things, but it's a very good starting point in doing your designs. I hope this was interesting. Thank you.